Hello, I'm Isaac Ajao. I want to talk about data cleaning and preparation using Stata. I will demonstrate how we do that with an example. Look at this data. This is about, it's a medical data. These are names of patients, these are their ID, these are their ages, these are their gender. We have diagnosis results, blood pressure, BMI, which is a body mass index. Now, how do we fill all these empty spaces? These are missing values. This value you cannot. This is not analyzable. We have to fill these empty cells. So how do we undo it? So I have a do file. I've written a do file for this. Let me open a do file. Look at it. So you can see now change my directory to my projects. Then either you are new to do file or you are not new. We use the do file for our code, the data, and the analysis. Now already I've created some folders where I keep my files, especially the data. So the data you see here is what I showed you earlier. This is it. So I've exported it. So, and that's why you can see it here. Now back to the do file. Now I've opened the data. You can see, assuming I want to use this, all these star you see here, they are comments. We use star for comments to run comments. Comments are not going to be analyzed on Stata. So use data. This data is the name of the folder I've created. So the data contain all these files. Okay. Now you have this. I want to check for missing the values now. As me, I want to check the missing values. So we use this. Say mix table summarize. That means if you summarize the missing values, mix table is a command. If you want to know more about mix table, come here and type help mix table. How do we use it? Starter will give you a lot of information about how to use mix table. And here you will see how to use the examples. You can see. So these are examples. It will just summarize how many missing values we have. Then you summarize how many missing values you have, then you know how to go about it. So replace, once you have identified the missing values, the next thing is to replace them. So when you look at each of these, you can see that the first column, which contains the name of the patient, none of the cell is empty. So it means it doesn't have any missing values. Then you go to name, the gender of the patient. You can see the sixth row contain empty space. It has to be filled. So, and that's why the another one, the gender contains missing values. Then the diagnosis also. Diagnosis contains missing values. Blood pressure contains missing values. Then BMI also contains missing values. So these are the area where I'm going to work. So we replace the missing diagnosis with unknown, followed by, you see, when you replace diagnosis with unknown, this is how to do it. You just say replace. Replace a common term we use in diagnosis, in Stata. Replace means, you want to replace one of the categories Diagnosis has two categories. Look at it. Diagnosis variable contain, is it two or three categories? It has hypertension, diabetes, it has stroke, it has cancer. Just like gender contain two categories or two levels, male and female. So that is how to do it. Then we now come back. What you want to replace with is going to be there. So whenever we have, so this is how to do it. Since you have identified, let me just run this for you to see. I'll run this now. Means table. Run. Come and see it here. Run, then we see the result. So this is means table. Summarize. It means each has two observations. You see, those are missing here are two. Blood pressure has two missing observations. BMI has three observations, three missing observations. So you can see each has two missing observations. Gender has one. Diagnosis has one. Blood pressure has two. BMI also has three. So those are the ones we have. Then you can see that it just went straight to those that are numeric. The numeric one are the most important. We can replace all this one with unknown. And we can also replace all of these values, the empty space for numeric variable with the mean of each of the column. The mean, we normally use the mean or the median of the column to replace the empty space. It's scientific. It's acceptable. So that's the summary you have here. You can see. Now we have to do something about the remaining one. So this is the do file. That one has given to us. So you replace the diagnosis with unknown, because diagnosis, they are not numeric. They are string variable. So anywhere you see empty, just put unknown. Gender, you can't say, you can't predict, you can't. There's no way you can say somebody is female, why is female. So it's better to put unknown there. So this, if diagnosis is equal, two equality sign, that's what we use in Stata for replacement. And this double quote means empty. Same thing with that of gender, empty. So we are replacing, now for example, we want to replace that of blood pressure now and BMI with the mean, as I've said. Blood pressure, is numeric variable. So sum, you want to sum, you are asking this how to do it. Sum blood pressure, you sum to calculate the mean now. You sum. Normal in mathematics, you want to calculate the average or the sum or the mean of a variable. You are going to sum over the number of items, then you divide by the number. So this one is mean only. So sum blood pressure, this is blood pressure, sum everything, divide by the number. You can see, divide by 10. So it's going to give us the mean. The mean of this particular variable is going to be put inserted to this and this. The same thing I'm going to do for BMI. So the same thing I'm going to do for BMI. You can see replace blood pressure. This R means, this it will take it like a vector. So the mean. So if missing, you can see missing in blue color. So if it's missing, anywhere you see it, what this one says that we are asking Stata to replace wherever any cell, any value is missing with the mean. With the mean that have been calculated here. The same thing I'm going to do for BMI and any other numerical variable there. So that's how to do it. Then identify duplicates using name and age. When we have, names are not supposed to be repeated. Though I don't do that, but you can do it. Once your name, you know that your name, some names are repeated. Maybe it's in the same person. Of course, you can have two people behind the same name. Except we have that. It's not allowed to have any name repeated. So in any case, if you want duplicate to be reported, for example, you want to duplicate of name and age to be reported, it is how to just type duplicate. Many of the code we use in Stata, they are English word. In fact, the word we use in English and the one we use are code. So it make remembrance of those code easy. So let me run each of these. Okay, let me just, or maybe Okay, well, I can run everything together after I've explained it. So now this, you can see this duplicate report name H. It will give us duplicate. Let me just run this, or let me run all of this one I've just said now. See the result. Can minimize this for us to see. You can see it has done it. See the blood pressure, the mean has been given. Those empty spaces have been filled. You can see the unknown are already there. Okay, I didn't do that of H. If I'm waiting for H will always be, you can see, unknown is here, unknown is here. Those missing values, they are all here. So for H, I can quickly write that. For H, replacing blood pressure, let me see. What I need to do is just say H. I'll just copy the same thing. So H, me only replace H, mean if missing H. Okay. Let me run it. Run. Let's see. You can see it has done it. So right, let me move on and save this. So the next one, so I can run all of this. So the second one is to check for duplicates, which I've done, and you can ask Stata to drop the duplicate, and you can also tag those that are having duplicate. Tagging means you want to separate them. You want to let them stand alone and easily know them that these ones are duplicates. So then you want to recode. You see, you need to recode because we normally do recoding. Even it's not only in Stata. Every software we use in 36, R, Python, MATLAB, all of them, even SPSS, we do that because we must generate. When you generate a variable, that is when you can recode. We do encoding and we do recoding because as I normally say, computer doesn't understand English, it doesn't understand any language. We use code, and so diagnosis, diagnosis has hypertension, diabetes, stroke, cancer, and unknown. So we need to replace each of them. I just choose to use one for, can see, replace diagnosis code. You have generated. You must generate another variable which will be empty. This is it. Generate diagnosis code dot. So dot will be there. Let me generate this for you to see. Generate. Can see diagnosis code empty. We now be replacing. This diagnosis. We want to replace each of these by 1, 2, 3, 0, like that. So this has to do it. As if I can do it without writing all this code, I just go to the menu and do it, but it's better to do it this way. So replace diagnosis code. You are replacing this new variable. So you are giving a condition. Diagnosis code is equal to 1. If diagnosis itself, as I put in diagnosis code, is the newly generated variable. So if the diagnosis code, the original variable, if it's hypertension, hypertension is there. You must make sure that the way it is written here is the way it is written in the original data. Let me show it. You can see hypertension. You don't go and write small letter, lowercase of h here. It must be written the way it is written in the original data. Otherwise, you are going to do a wrong coding and you affect your results. You can see the way it is written is the way I put it here. So I put 0 when the health challenge is unknown. You can see. Then you now label the variable diagnosis code. Diagnosis as numerical. This is the label. Label is the name we give to the variable, the real name of the variable. I just put diagnosis, but the one I just created now is diagnosis code. So if I run this now, you will see it done. I want to create new variable and categories for the ages, for each category. Each category You are going anytime you want to create new category, or you want to change the name of the categories or levels, you need to generate another variable in Stata. That is the way you do it. And so you create just as we created one here, you're going to create another one. I call this one age group. You know the age we have here in health, in medical statistics, we value certain things. Age is very, very important, and we use age group. Age group. We have standard age groups like 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, 20 to 29, and so on. So, but some don't follow that. But we prefer using age group, not just the individual ones. So now to do this, what we need to do is to create a new age group which we want to do. So under that, we now do the replacing, just the way you just really want it. So age group equals under 50. If age is this is what we want. We want it this way. So if age is less than 50, start to understand all this this sign. It recognizes less than, it recognizes this is greater or equal to. You see. So when I run this, we see the way it's going to do it. No, we have not started analyzing. We are just cleaning the data. We are cleaning. We are preparing. It's just I call this video. I say it is a data cleaning and preparation in Stata. So we are still preparing data for analysis. Now 50 and above is if age is greater or equal to anything you define here is what you are going to use throughout. So we have to be very, very careful here. Then for BMI, we want to flag. So where if overweight, we are defining because we only have BMI. See, let me show you the data. We have BMI, but we can't say somebody is overweight or is underweight. No. So but we can decide it here. If it is greater than a particular value, we can see this person is overweight or normal. So and we can have underweight also, but that's just the way I want it. Now replace what you can see each time I want to make replacement, I'm generating new variable. So generate overweight. I want to see those that are overweight with this BMI. I want to know patients that are overweight. I want to know those that are normal. So replace overweight is equal to 1 if BMI is greater than 25. Replace overweight is equal to 0. We are using overweight. Overweight is already, we have generated overweight. So we need to be replacing this using the existing data. Variable BMI. BMI is already existing. We are generating overweight from it. BMI, but there's no overweight. We must generate another one. You call it overweight. Let me run it. You see now. If I run generate overweight, run. See it coming up. You can see overweight. So by the time you are replacing, you will see this place fill up. Stata is very easy to use. So label define. This OW I just put here, I can put anything, but I must be consistent. OW means overweight. So assign 0 and that will call it normal. Assign 1 and call it overweight. So we now label the values overweight, and wherever you see overweight, call it OW. Then log close. I open the log here to keep my code and the result. I must close it. So let me run everything to save time. Run everything. Yes. Run everything. I've run everything. You can see this is 21st May 2025. The time. Run everything. Results are here. Everything. So let me go back. See. See, that's done everything. These are the duplicate tags. These are diagnosis code, age group generated. You can see overweight. See overweight. The weight only 2 are normal, considering their BMI. What gave us permission about this one at the BMI? Thank you. It's not more than this.